Hello everyone. Today we will be beginning section 5.4, which is multiplying and dividing rational expressions. This can be found on page 327. Before beginning this section, you should have reviewed how to factor either on your own or by watching the video I shared previously. Okay, if not, then this will be very confusing. So I'm going to be looking at examples from the skill practice, which can be found on page 331. The first example will just be simplifying. Okay, so let's look at this. In the numerator and denominator, we have trinomials. Now, when you look at it and you're trying to simplify, the first thing you might think is, oh, maybe these 14s can cross out and turn to 1. Same thing with these x to the second powers that are on top of each other. If you think to do that, you will get the problem entirely wrong. So be very careful. You cannot just cross things out. And the reason we can't do that is because we're showing here addition and subtraction signs. So you have to go to your factoring. I noticed that these are trinomials that start with a leading coefficient of 1. And as we reviewed, this would be a product and sum problem. Actually, both of them are. And that doesn't always happen. They're not always going to be the same factoring in the numerator and denominator, just for this example. Okay, so how this works is the last number is your product, and the middle number is your sum. So you have to think of two numbers that multiply to be 14, and when you add them, add to be -9. If you want, pause the video and see if you could do that. Those numbers would be -7 and -2. So the numerator now turns into x minus 7, x minus 2. Now the denominator. The denominator, the product is -14 and the sum is -5. Again, product is the last number, sum is the middle number. So what two numbers do that? Pause the video, see if you could figure that out. And that would be -7 and +2, right? So now the denominator turns into x minus 7 and x plus 2. All right, now in this lesson, once you have factored, the rest is easy. You're basically looking for something that's the same, and now you can cross out because it's in multiplication form, right? This means x minus 7 times x minus 2, x minus 7 times x plus 2. So because it's times, now we can cross things out. So what's the same? These two are definitely same. Now these two look the same, but they're not because of the sign. So you can't cross them out. So that is actually your answer. What remains? X minus 2 and x plus 2. And I took away the parentheses because they're not being multiplied by anything anymore. All right. So again, that is how you simplify. Now I will show you how to multiply. The next problem I'll be looking at is number 29 on page 332. This will show you how to multiply. So it says x plus 5 over 4x minus 16 is being multiplied by 2x to the second minus 32 over x squared minus 25. Okay, so again, you should have reviewed factoring because now I've picked a problem that has different types of factoring. So the first thing is you just go numerator, you then check the denominator, see whatever you can factor, you factor. So x plus 5, can it be factored? Is there a method that can reduce x plus 5? The answer is no. There's no common factor. There aren't 3 terms, so I can't do product and sum. So this is going to remain as x plus 5. Great. Now let's look at the denominator. The denominator is showing a common factor. Remember, the greatest common factor. What number can they both be divided by? Please pause the video and see if you could figure that out. And you should have figured out that the greatest common factor is 4 because 4 can go into each term. So what's left when you divide each of these terms by 4? You're left with x minus 4. All right. Now we look at the other fraction. Okay, let's start with the numerator. In the numerator, I'm noticing that these terms can both be divided by 2. So that's going to be my first step. Divide them each by 2. So that would be 2 parentheses x squared minus 16, right? Because I divided them by 2. Now, I am not done here because here I'm left with difference of squares. That means that these can both be square rooted, right? And that would result in x minus 4, x plus 4. One more time, if you didn't watch the factoring video or reviewed factoring, you are probably very confused as to how I got that. Now, in this denominator, I'm noticing that I have another difference of squares, and this time there's no common factor. So go right into the 2 parentheses and do difference of squares. So that would be x minus 5 and x plus 5. Now comes the fun part. And I'll use a different color pen here. Now the crossing out. What is the same that's either top and bottom from each other or diagonal from each other? Well, I see clearly this x plus 5 and this x plus 5 will cross out. X minus 4's cross out. And that's about it, right? So I'm going to just write now what's left over. The 2 is left on the top with an x plus 4. And the 4 is left on the bottom with an x minus 5. So I still have to reduce here because 2 over 4 is the same as saying 1/2. So that would be 1 times x plus 4 over 2 times x minus 5 because I reduced that fraction. Also keep in mind that you don't need to write that 1. I just wrote it there so you don't get yourself confused. But that's it. That is your final answer. All right. And that's how you multiply. And lastly, we will do a dividing problem. So let's take a look at number 40 on the same page. So 40 says 3x squared. And I tried to pick problems that have all the type of factorings talked about in the previous video. All right. So this is how you divide. So the first thing you want to do, just like in the previous problem, is factor. Factor whatever you see can factor. So right here in this numerator, this is the Australian method, okay? That's because there's a leading coefficient here other than 1, and it's not the greatest common factor. So let's go right into the method. You want to take this number, multiply it by the last, that's your product, and your sum is still the middle number. So you're looking for two numbers that multiply to be 12 and add to be 13. Pause the video, see if you can figure that out. And that would be 12 and 1, right? Because 12 times 1 is 13 and 12 plus 1 is 13. 12 times 1 is 12, sorry, and 12 plus 1 is 13. So now the method works like this. You write the numbers, you put fraction bars under each one, you take that first term, take away the squared, you're splitting up the squared. See if you can reduce any of these fractions. Yes, 12 over 3x can reduce for sure right here. This would be 4 over x, or 1x if you want to write the 1. The second fraction does not reduce. So once you have reduced your fractions, you go bottom to top. So this would be x plus 4, 3x plus 1. So that is your numerator. That's this guy right here. Okay? Now for the denominator. Denominator is clearly a difference of squares. So that's going to turn into the square roots, x minus 2, x plus 2. Okay, moving on to the second fraction. Well, actually, before I move on to the second fraction, I want to show you what we're going to do with this division. This division is going to come down as a multiplication, and the second fraction, the one that follows the division, is always going to flip. Okay, that's how you divide. So you're just multiplying by the reciprocal as you do in basic math. Okay. Now, I have one last thing to do. I notice right here this denominator can factor. It does have a greatest common factor. So let's rewrite the entire problem. And let's factor that. The greatest common factor is 4. Divide each of those terms by 4, and you're left with x plus 4, right? Divide by 4, divide by 4. That's how I got that. Okay, now comes the fun part. Let's do a different color. We'll choose blue this time. Okay, what's the same diagonally or top bottom? I see x plus 2's are gone, and I see the x plus 4's are gone, right? So now what is left over? In the numerator, I only have a 3x plus 1. No parentheses needed because it's not being multiplied by anything. And then I see this x minus 2 is left and this 4 is left. So we're just going to write it like this, always with the coefficients in front. Now, if you want to go ahead and distribute that too, you can. Distribute the 4, you can, but it's really not necessary. You can actually just leave your answer like that. Okay, so to make a long story short, dividing and multiplying are the same, except when you divide, you have to do the extra step, which is change it to multiplication. And again, always flip the fraction that follows division. Okay? All right, hope this helped. Have a good one.